Once again, I know that I want to find the derivative to this function f of x because they asked me to find the gradient exactly when x is 2, so that is at a specific point. We're going to once again use the definition. The definition to find the gradient at a specific point is using the derivative, and that means that I need to find the limit as h tends to 0 of f of x plus h minus f of x, and that's all over h. Remember, we first need to find out what f of x plus h is going to look like. So I'm going to, on f of x, everywhere where I saw an x, I'm going to replace it with an x plus h. So my derivative is still going to be the limit as h tends to 0, but this is going to be for 2 minus x plus h minus 2 x plus h squared. And then remember, when you minus the function, the original function, you must put it in a bracket because it was more than one term. So that's going to be minus 2 minus x minus 2x squared, and still all over h. Like we did before, our next step is to simplify our numerator. Simplifying my numerator, I'm going to get the following. 2 minus x minus h minus 2x squared, and then minus 4xh minus 2h squared minus 2 plus x plus 2x squared all over h. Clearly, I can simplify here by adding like terms. I can see that if I add 2 and minus 2, they cancel, as do minus x and x, because they add up to 0. And also minus 2x squared and 2x squared add up to 0. So now, taking out an h as the highest common factor, in my numerator, I'm going to have h into minus 1 minus 4x minus 2h. Notice I don't even bother to take out the common factor of minus because there is no minus to cancel from the numerator to the denominator. So all I take out is the part that can cancel. I'm now left with just a numerator, and my 0 denominator has been removed. In other words, my derivative is now given to me with the expression of minus 1 minus 4x minus 2 times 0, and simplified, it means that the derivative, which is the gradient of the tangent to my specific point, is going to be minus 1 minus 4x. But that's not the end of the question, because they ask me, what is the derivative going to be exactly when x is 2? If I want to find out the derivative when x is 2, all I do in my derivative expression is I change the x to a 2. In other words, the derivative, the gradient of the tangent, at the point when x is 2 is going to be minus 9. Let's take a look at this and see if this is in fact the case. In this slide, you can see that I've drawn the graph of f of x. I've also drawn the tangent to f of x when x is 2. Let's take a look at the gradient of that tangent. Remember, a tangent is a straight line that touches my curve at one point only. If I take a look here, I can see very nicely that the gradient of my tangent is minus 9, and that is exactly what we found by using the definition.